This video is for Chemistry in the Earth System, Unit 3.4, Lewis Structures and Molecular Geometry. Today's essential question: how can the electronegativities of atoms be used to predict the types of bonds in molecules? How can the electronegativities of atoms be used to predict the types of bonds in molecules? Our first main idea: electronegativity. Electronegativity is the measure of an atom's ability to attract electrons. The unit of measurement for electronegativity is called the Pauling, named after an important American chemist, Linus Pauling. Nonmetals have a greater attraction for electrons because their valence shell electrons are closer to a complete octet. In the periodic table, electronegativity increases from left to right and from bottom to top. The first three periods of the periodic table show these trends. The inert gases, meaning the noble gases, are not included because they rarely form bonds. The difference in the electronegativity of two atoms is a good predictor of the type of bond that will form between them. If the difference is large, the bond will be ionic because the bonding electrons will be transferred completely to the more electronegative atom. If the difference is small, the bond will be non-polar covalent and the bonding electrons will be shared equally. If the difference is moderate, the bond will be polar covalent and the bonding electrons will be shared. However, the electrons in the bond will be pulled toward the more electronegative atom. In a molecule with more than two atoms, the electronegativity difference is calculated separately for each bond between two atoms. The table on your screen here gives the approximate ranges for these three types of bonds. However, the dividing lines between the three types of bonds are not definite, and sometimes classification depends on the types of atoms involved. A sample problem. Use the electronegativity values listed in the periodic table. Again, for you, is going to be found on page 90 of your notebook, to predict the type of bonding in each of these molecules. Number 1, magnesium oxide, MgO. Once I access these electronegativity values, I see that magnesium has a value of 1.2 and oxygen has a value of 3.5. The difference between these is 2.3 Paulings. Therefore, this bond is ionic. Number 2, chlorine, which is Cl2, because it is a halogen. Well, chlorine has an electronegativity value of 3. So the difference between 3.0 and 3.0 is in fact 0 Paulings. And that makes this bond non-polar covalent. Lastly, number 3, SO2. So I see that oxygen has a value of 3.5 and sulfur has a value of 2.5, giving us a difference of 1.0 Paulings, and that makes this bond polar covalent. At this point, you should be able to generate a full and appropriate response to today's essential question: how can the electronegativities of atoms be used to predict the types of bonds in molecules?